All right, so here is question number 8 from the chapter 14 homework. So it's 14.4.22 is the question number. And so really the only way to do this is kind of start with what you have and build. So the first thing I'm going to do is I'm going to go ahead and export this or open it to Excel, because that's going to let us save a little bit by using the Excel regression analysis tool. All right, so there's our, oops, I don't know why it's going so slow. Okay, it's being a pain. All right, there we go. All right, so first thing I'm going to do is I'm going to come up here to data, run data analysis. If you don't have it on your computer, you may have to add it at the add-ins like I showed you earlier in the semester. We'll choose regression, hit OK. We'll give it our Y input range, which is these B values, and our X input range, which is these A values. And then our output range is just wherever we want it to show up. Right now it's set to E4, which is fine with me. So I'll hit OK. And there's my regression output. The only thing that really we're getting from this that isn't already given to us in the problem information, because you can see the slope and the y-intercept are already given to us up here. And the SSE, or sum of squares residual, is here. Residual is what it's called in Excel. And then it's giving us the standard error, which isn't given to us here. So that's something we would have had to calculate. So at least it did that for us. So really, though, all you're going to do is, like in anything else, you're going to start with what you know and build from there. So we know that we're talking about constructing this confidence interval for an x value of 6. So I'll start with that. My x is equal to 6. And we know that we're going to need our y hat. That's this little thing, y with that little hat on top of it, which is our predicted value of y for our given value of x. So all we do for y hat is say it equals 5.165, or I can take this number right here, plus 0.556 times our value of x. So what we're really doing is working this straight line equation, and you don't have to use the info off of this regression output because it's actually given to you here in the problem. I just went ahead and did it because the same information is here and I don't have to type it out. So what we're saying is if x is 6, we predict y will be 5.5. Okay. SSE, again, this is given to us in the problem right here, 9.167. We know our confidence is 0.95, which means our alpha is 0.05, right, or 1 minus the confidence level. Okay, so I think that's all the information that's given to us. So now we're going to have to calculate our confidence interval. And unfortunately, there's a really big, nasty factor in that confidence interval we're going to have to figure out using Excel. And it's super easy to make a mistake because there's so many arguments. So the confidence interval is our y hat, or our predicted value of y, plus or minus our critical t, times our standard error, times this really big factor. And the really big factor is the square root of 1 over n plus x minus x bar squared over the sum of x squared minus the sum of x squared over n. Okay, so it's that big formula on page 665 in the book. In fact, before I even go any further, let me go ahead and figure out what my sum of x is, and then my sum of x squared, and that will help me a little later. So there's my sum of x. Here I can do x squared, which is just going to be each x value squared. And then I'll take a sum of that as well, because I'm going to need those to work out my little factor. Okay, so I can find my critical t just by doing t dot inv dot 2t for our probability. We'll have 0.05. Our degrees of freedom is going to be n minus 2. So our n for this problem is 5. Say 5 minus 2. Better yet, let me create a little more space here. Put in n. And then that way this is functioning as a calculator. Okay, so there's my critical t. I also know that my standard error is going to be given to us right here. So I didn't have to type that in. I could have just used it from there, but I just like to have everything together. And now I have to do this great big factor, which again is the square root of 1 over n plus x minus x bar squared over the sum of x squared minus the sum of x squared over n. Okay, so this is the big, I call it a factor. There's probably a name for it somewhere that some smart guy came up with, but it's the factor that we're going to multiply all of this by. So it's so big that some people prefer to break it into pieces. So I'm going to do that. So the first part of it is 1 over n. That's pretty easy, right? Because it's just going to be 1 divided by our n. The second part is our x minus x bar squared. And again, that's not too bad. So what we're going to do is we're going to take our value of x, and then we're going to subtract x bar. Now, x bar is the mean of x, right? And so we don't have that given to us. What we have to do is take our sum of x divided by n, and that's going to give us the mean or x bar. And then that whole thing is going to be squared. So the whole x minus x bar squared. All right. Now the denominator portion is the sum of x squared minus the sum of x squared over n. So I'm going to say this equals the sum of x squared, which is this number right here, minus the sum of x and then we'll square that over n. So there's the denominator of that whole part of the factor. So the whole factor then is the square root of all this. So I'll figure out the factor, which equals the square root of 1 over n plus x minus x bar squared over the denominator, which was that big complicated part. And that gives us our factor. All right, so now our margin of error for this is just going to be our critical t times times our standard error times the factor. And now we can do the upper confidence limit and the lower confidence limit simply by taking the y hat plus the margin of error, and this is going to be the y hat minus the margin of error. And hope we didn't make a mistake in all of that. That's it. So hopefully that was helpful to you. You just have to break it down one piece at a time. Some people will be comfortable doing this whole factor as a single thing in Excel. I just find it easier to break down the parts of it, the 1 over n, then the numerator, which is the x minus x bar squared, and then the denominator, and then figuring out the factor, which is the square root of 1 over n plus the numerator divided by the denominator. And then again, your margin of error is just your critical t times your standard error times that factor. And then you add that to the y hat and subtract it to the y hat to find the confidence limits. This exact same formula and everything works for the next problem, question number 9. And then question number 10, it won't work and it'll confuse you, but in that one, you're not doing a confidence interval, but you're doing a prediction interval. And that is, it's almost exactly the same, except the factor has one more element, which is, instead of it just being 1 over n times x minus x bar squared, plus x minus x bar squared, it's 1 plus 1 over n. So just take a look on page 667, and there you'll see the formula for the prediction interval, which is just slightly different. Anyway, I hope that's helpful to you, and I hope you can get through the rest of these problems without too much frustration.